Welcome to week 5. I'm sorry that this lecture was a little bit late getting started. I got kind of hung up in another class, but it is important that we talk about more of the theory involved in cinematography, and lighting is one of the very important topics that we're going to be covering today. And so lighting is really basic to video production. It's foundational, meaning that if you don't understand lighting, there's only so good you can make a movie. I mean, I'm just being honest with you. Now, that doesn't mean to say that you can't have movies that use mostly natural light and things like that. It doesn't mean you can't have a little bit of latitude in what you consider lighting. But bad lighting is bad lighting. And so we can't have it. Its production values are important. You cannot have bad production values, and lighting is one of the key ones. And so that's why we're talking about it now. And we're going to basically introduce the concept of lighting from the ground up. Okay, so lighting, more than just illumination. Now, let me just say one thing about that. Illumination is lighting something up so that you can see it, meaning that when you get your passport photo taken, as long as they can identify you, it doesn't matter if you look like crap. I mean, honestly, that's just the way it is. And so if all the purpose is to make an identification, then any light bulb will do, or an open window or something like that. But if you want to make something stand out, if you want to, like for example, advertise something, if you want to make an advertising image look good, you have to know something about lighting. You have to bring out the details and maybe, suppress some things that you don't want to see. And so that's why we talk about this in the first place. Now, what is light? That's another thing that's important to understand going into this. Because people don't always understand what light is. For example, when you think of the moon as a light source, it isn't really a light source. It's reflecting light from another light source. And so not everything is as it seems. But what is light in itself? Well, light is radiation. And when we hear the word radiation, we think of nuclear power and things like that. But really, almost anything can be considered radiation if it's energy of some kind. And light from the sun contains far more than the visible spectrum. For example, if you get an X-ray taken, that is a kind of energy. It is a kind of radiation, but the light from the sun contains a lot of X-rays. Also radio waves, ultraviolet, infrared, and things like that. And so there's a lot to what light is. Fortunately, we're only talking about the visible spectrum. Light and heat are the same thing. But the reason why it's important to know this is that if you feel warm and you notice a light is pointing at you, that might have something to do with it. Because light and heat, again, are very similar. Another factor is that if you're looking at like heat-seeking night scopes, night vision, and stuff like that, understand that there are different kinds of lights. Some of them are outside the visible spectrum that can provide illumination as well, and occasionally that comes up useful. Light travels in straight lines. So basically, you got a ray of light. It's going to go on forever in the same direction until it hits something. And really, that's what it is. Now, it may weaken, it may dissipate over time, but overall, light just keeps on going. And the way we know that for sure is that if we look out at the stars at night, the light that we're seeing from those stars actually started its journey here, in some cases, thousands of years ago. And we're just seeing it now. Because the light just kept going. Okay, light cannot go around corners. Again, light goes in straight lines, and so if there's a wall between you and the light, you're not going to see the light unless it's reflected off something else. The light isn't going to go around that wall and come and find you. Now, sound will, but light can't. Okay, light also increases 4 times every time the distance is halved. Now, that's kind of an interesting thing to say. That's the inverse square law. So, for example, if this is you, and you got a light here, and the light source registers, say a certain amount of IREs, you got 100 IREs, and then you double the distance, you're not going down by half, you're going down by 75%. So every time you double the distance, you lose 75% of that source. And if you cut in half, you don't double the source, you multiply it by 4. And so that means that you've got to be very careful when you move lights in or out. That can have a bigger effect than you might imagine. And so it's important to know that's the inverse square law having to do with light intensity. And there are three things light can and will do if it strikes an object. This is very basic. How does light work? When light hits an object, what does it do? The first thing light can do is it can be absorbed. And so that means basically the light is coming towards the object, hits the object, stops. No more light. Light has stopped. And so that basically means whatever it hit absorbed the light. It's just sucked it in and it was gone. So what sorts of objects do that? Objects that are dark, something that is black, will absorb light. And the way that you can tell is the light hits this and it just stops coming. It doesn't really bounce off, or not much of it bounces off. And so it absorbs more light than it bounces off. So when light strikes an object, it can stop. Dark objects absorb light. And when light stops, we see darkness, which is not always absolute, meaning that they do have this material which supposedly absorbs all light, which basically makes it, for all practical purposes, invisible. But most objects, like for example, most black pigment, if you're going to try to create black paint, it's physically impossible to do that. It at least used to be. You'd have to create really a very dark blue. And so there's certain limitations to that. And dark objects reflect less light than they absorb. And conversely, light can be reflected. When light strikes an object, it can bounce. And so instead of just stopping when it comes to the object, it comes back. It bounces off the object. And usually that's going to be strategically. It's like a ray of light's going to go like that. It's going to bounce off in a different direction. And so the object will reflect light in that fashion. Light objects reflect light. If you have a white object, a white piece of paper, that will reflect all the light spectrum back at you. And it will appear like a light source, even though it isn't. And when light reflects off an object, it can appear to be a light source. I talk about the moon, which I just mentioned. Objects can absorb frequencies of light and not others, and so therefore, if I were to say that this is orange, what I mean is that white light is hitting this, most of it's being absorbed, except for orange. Orange is allowed to pass out, and so the same thing would be true if I had something that was red. It would absorb everything but red. And so that is why we see objects and call objects different colors. And so we could see a red light like a traffic light, and that's a slightly different thing because what we're seeing is transmitted light, not reflected light. And I think we've pretty much covered that. Light can also be refracted. Now what that means is that when the light hits the object, it goes through it. So light keeps on going. And so the object has let it pass through. Like, for example, glass can transmit light, but really it's refracting it. Light can pass through an object. This is called refraction. Clear objects all like to go through them, but not unchanged. And that's important to understand. Because unless you're in outer space, light will bend when it goes through something. So water, for example. If you're walking through a lake or something like that, and you see something at the bottom of the lake, you reach down and get it, and you find out it's not there, that's because the water actually refracted the light that you saw, and it was really somewhere else. And the same thing actually works with air as well. Air refracts light, and glass reflects light. You can use lenses and things like that. So all these things are ways of refracting light. Now, light also comes in two basic characters. The character of light, let's say. One character of light would be hard light. A hard light is a light that produces a very hard shadow. And so hard light is from a small light source. And so this could be a small point source of light like an instrument or the sun. Hard lights creates distinct shadows, and this brings out details in the surface. And so if you have a rough surface, it may look smooth unless you have a hard light. The hard light's going to bring out those by creating shadows. The sun on a bright day or a small instrument. So those are examples of hard light. Soft light is basically the opposite. Soft light, you have a large light source. And the soft light creates fuzzy shadows or no shadows. If you're on an overcast day, you don't see shadows, that's a soft light. If you're using a very large lighting instrument, that will also give you that effect. And basically that's how soft light works. It's kind of cottony, like the clouds. Really the light's coming from the whole sky and not the point source of the sun. Now, three-point lighting is the basis of all studio lighting. In three-point lighting, you have lights that fill certain roles. And so, if you look at the diagram here, if you've got a person standing there, you get a key light hitting them from an angle. Now, the key light represents the sun. This is supposed to be the sunlight. Usually, the key light is above eye level. And usually, the key light is of a slight angle to the audience. It's not hitting them head on. It's hitting them from an angle. And the key light is generally a hard light. Usually this light is intended to create shadows, to bring out some details. Now the fill light fills in shadows. It softens the shadows. Basically, it doesn't eliminate the shadows. It only fills some of them in. And the fill light is either going to be head on or it's going to be off to the opposite angle as the key light. And it's generally a soft light. It's not creating more shadows. It's only dealing with the ones that are already there. And the backlight can be directly behind the subject. Usually it's off to one side. The backlight usually is high above eye level, and it's hitting the subject on the shoulder or the top of the head. And that backlight is providing three-dimensionality. It brings out some of the details of the person. Lighting tips. Here are some basic things that people get wrong on the first time. First of all, avoid backlighting. If you are lighting somebody, in which case they're in between you and the light source, you're going to get a backlit image, which basically means you can't see the details of the person's face or whatever you're shooting. Don't shoot into the sun, keep the sun behind you. Really, that's all it is. You can fix this by simply moving a few feet, and backlighting ruins detail. Unless it's for an effect, I would recommend just not doing it, because it used to be that it was pretty much impossible to do in video because it would screw up the image. Now, another example is the newsreel effect. We call the newsreel effect. Now here, we have a subject that has no shadows. Their face is kind of bleached out. And that worked because they had a head-on light hitting them directly in the face, probably mounted on top of the camera. So it did not create useful shadows. It basically created an evenly lit face, which you can't see much detail in. Makes them look washed out. Please avoid those two effects. Bring lights. Bring lights with you. The lighting kit is very lightweight. The lighting kit is light. And we have two lighting kits. One of them is heavy, I'll admit that. The other one is much more light. Or at least bring some lights. We have plenty of lights. Don't rely on chance. Don't pretend. Don't think that you're not going to run into a situation where you simply need light. Use lights to make a statement. Plan on lighting. Try to make it look good. Production values. Understand three-point lighting even if you're not going to use it. Meaning that if you want to put your key light down below eye level, at least know that you're doing it that way. At least know that you're moving your key light below eye level. And always respect production values. Make sure that your audience can see what it is you're doing. Lighting instruments. We have three basic types of instruments, really four now. Natural light. We'll call that out first. Natural light is sunlight, and if you put up a reflector or a flag or something like that, you can bounce sunlight into your subject, and you can basically create a second light just by reflecting a light that's already there. So natural light would be one type of lighting instrument. Reflectors and absorbers allow you to do that. Tungsten light is traditional. Now, tungsten light is a light that comes from a standard light bulb, the kind that Edison invented. And so basically it's a little strip of tungsten metal that's glowing, and that is emitting light. Tungsten light is orange. It's also very hot. Eventually you're not going to remember this, but it used to be you could burn your fingers changing a light bulb because the light bulbs are hot. Tungsten lights are hot, so don't touch them when they've just been on. Fluorescent lighting has a washed out look. Fluorescent light tubes, they don't give off a lot of heat, but they're generally a soft light, and they've got serious problems. I would go through a lot of trouble not to like my video with fluorescent light. And that includes compact fluorescents, those squiggly types. Those are also very dangerous if you break them. I try to avoid them altogether. LED light panels are a new thing in town, and honestly, I like them. They're very good, particularly at close range. LED lights are wonderful at close range because they don't give off any heat. You can have it inches away from your subject, and they don't feel the heat. So that's a great thing. They tend to be very relatively soft because you're getting the whole lighting panel, although they do have some more expensive ones where they're concentrated light. But I wouldn't necessarily say that's the only way to do it. But definitely LED lights are a viable option, and we do have some of those for you to use. So those are just some basic facts about lighting, and you will be expected to understand the difference between hard light and soft light, different lighting instruments, and of course 3-point lighting. And you'll also be expected to use that in the work that you produce here at Methodist.